Ankylosaurus originally had 91% of its genome mapped before Hurricane Clarissa struck the island. It was then successfully recreated by InGen in the Embryonics Administration Lab on Isla Sorna in secret after the acquisition of InGen by Masrani Global Corporation and after the passing of the Gene Guard Act. The ankylosaurs were parented and fed in captivity until InGen abandoned the lab and released them into the wild. Being bred illegally and far after the Jurassic Park incident, it was not planned to be an attraction in Jurassic Park. In the script for The Lost World, Robert Burke claims to have seen the remains of an ankylosaur herd while he was in the helicopter that transported him to Isla Sorna, and Burke further claims that they have gone extinct once again. Also, 2 scenes of Ankylosaurus were removed from Jurassic Park 3. This is included a battle between an individual and a pack of Velociraptor and a more peaceful scene of a herd of 3 crossing a river. After being cloned and experimented on for a period of 9 months in the late 90s, the unnamed InGen personnel set the dinosaurs free alongside the other illegally bred dinosaurs. Ankylosaurs roamed freely across the island for years to come, until they were illegally shipped from Isla Sorna to become eventual attractions in Jurassic World. Being created illegally and against the knowledge of InGen or Masrani higher-ups, it is unknown if the Ankylosaurus and the other new dinosaurs were affected by, or were even bred to include the lysine deficiency that affected the original dinosaurs. Ankylosaurus was a herbivorous dinosaur, though its wide muzzle suggests it was a non-selective feeder consuming ferns, shrubs, and possibly fruits. Its small, cusp-like teeth indicate it may have supplemented its diet with invertebrates. Fossil evidence shows where patterns on its teeth, suggesting juveniles chewed their food, while adults likely relied on hindgut fermentation for digestion. Despite its large skull, Ankylosaurus had relatively weak jaw muscles and limited chewing ability, favoring soft vegetation. Some researchers suggest its retracted nostrils and low tooth replacement rate indicate possible omnivory or digging for roots and tubers. Its nasal passages may have played a role in heat and water balance, and possibly even in sound resonance. The animal had a strong sense of smell and may have had limited stereoscopic vision. Its forelimbs bore most of its weight and were adapted for powerful movements, possibly for digging. Ankylosaurus grew progressively more robust, with juveniles developing reinforced osteoderms and fuse bones over time. Its armor was lightweight, yet highly durable, protecting against predators. The tail club was a powerful weapon, capable of breaking bones, likely used for defense or in intraspecific combat. Studies suggest it could swing its tail with great force, especially in adults. Some researchers propose the tail club acted as a decoy for the head, but this theory is widely disputed. Ankylosaurus was likely slow-moving but capable of quick bursts when needed. Its combination of armor, weaponry, and potential digging behavior helped it survive in the late Cretaceous ecosystem. In 1910, British paleontologist Arthur Smith Woodward described a partial theropod skull found by Lewis Bradley in England. The skull, one of the most complete theropod skulls from Europe at the time, is now housed at the Natural History Museum. In 1923, Friedrich von Huene proposed a new genus, Proceratosaurus, believing it to be an ancestor of Ceratosaurus, but the name was initially considered invalid. He formally validated Proceratosaurus in 1926 with a proper diagnosis. Despite being one of the best preserved Middle Jurassic theropod skulls, it received little scientific attention for decades. A CT scan and further preparation in the 2000 revealed new anatomical details. InGen successfully extracted Proceratosaurus DNA and created viable embryos, but the species never progressed beyond that stage. Despite this, a paddock was constructed before the 1993 incident. Proceratosaurus was one of the 15 dinosaur embryos stolen by Dennis Nedry from the cold storage room for Biosyn during the Isla Nublar incident in 1993. According to an InGen file leaked by the Dinosaur Protection Group, all viable embryos on Nublar were destroyed when water damage compromised the cool storage room. As a result, InGen lost all DNA samples during the evacuation of Site B, and the species was classified as terminated until new genetic material could be obtained. There is no evidence that Proceratosaurus was ever housed at Jurassic World, and any genetic material stolen by Nedry would have degraded by the time the Barbasol was recovered. Proceratosaurus possessed a nasal crest, which may have served as a display organ, but also possibly served to reduce bending stresses on the skull when biting. This may indicate it used a puncture pull strategy for hunting prey. However, it was likely not a big game hunter, lacking the bone-crushing teeth and extremely powerful bites of the Tyrannosaurids. Instead, it possessed an elongated skull, commonly found in basal coelurosaurs and basal tyrannosauroids. In the Lost World Park script, Corythosaurus was initially included but mispronounced as Carninthosaurus. It was meant to be captured by the InGen hunters, but was later replaced by the Parasaurolophus nicknamed Elvis. Though it did not appear in final film, it was briefly seen on a fact sheet before being swapped with Pachycephalosaurus in a continuity error. Roland Tembo also mistakenly identified Elvis as a Corythosaurus. However, Corythosaurus made a physical appearance in Jurassic Park 3. Its design for the film was influenced by John Sibbick's illustrations. The species was added to the riverbank scene in the script, but was mainly included in the stampede to increase dinosaur variety. The Corythosaurus in the film was created using the Parasaurolophus model. Corythosaurus had 97% of its genome mapped before the Isla Nublar incident. It was prematurely recreated by InGen, with enough data recovered to be included in an information sheet used by InGen hunters in 1997. After Masrani Global Corporation acquired InGen, the species was secretly cloned in the Embryonics Administration Lab on Isla Sorna. The Corythosaurus were raised in captivity until the lab was abandoned and the dinosaurs were released into the wild. Since they were bred illegally long after the Isla Nublar incident, Corythosaurus was never intended as a Jurassic Park attraction, though it appeared in the Visitor Center's restaurant mural. The released herds thrived in the northeastern jungles of Isla Sorna, often roaming alongside Parasaurolophus. In Jurassic Park 3, a herd of Corythosaurus and Parasaurolophus was seen grazing near an abandoned InGen compound. When Dr. Grant and his group fled from velociraptors, they ran through the hadrosaur herd, triggering a stampede. Studies suggest Corythosaurus was cathemeral, active at short intervals throughout the day. Its hearing was well developed, possibly as sensitive as modern crocodilians. The complex crest structure likely allowed for vocalizations used in communication, including warning calls and mate attraction. Scientists believe its calls resembled wind or brass instruments, producing low-frequency sounds that could travel long distances. Early theories incorrectly suggested Corythosaurus was aquatic, using its crest as a snorkel, but this has since been disproven. Juvenile Corythosaurus fossils have been found, but identifying young individuals is difficult due to their underdeveloped crests. Crest growth began when they reached half their adult size, distinguishing them from Parasaurolophus, which started crest development much earlier. Initially, multiple genera were identified based on size and crest differences, but later studies consolidated many species into Corythosaurus or Lambeosaurus. As an herbivore, Corythosaurus had a delicate beak suited for consuming soft vegetation. Fossil evidence suggests it fed on conifer needles, seeds, twigs, and fruits, indicating a browsing diet. Pentaceratops was a large ceratopsid dinosaur estimated to be around 6 meters long and weighing about 2.5 metric tons. Its skull was massive, measuring over 2 meters in length, with a small, upward-pointing nose horn. The brow horns were long and curved forward, giving it a distinctive appearance. Its frill was significantly longer than that of Triceratops and featured two large openings, or parietal fenestrae. The frill was rectangular and decorated with large triangular osteoderms, with up to 12 along the squamosal and 3 on the parietal bone. The rear corners of the frill had the largest osteoderms, separated by a U-shaped notch, a feature only recognized in 1981. Pentaceratops had a tall and broad torso, with long dorsal vertebrae spines that likely supported ligaments for balancing the heavy frill. Its prepubis was long, while its ischium was strongly curved forward. In smaller individuals, the femur had a noticeable outward bow. Like all ceratopsians, Pentaceratops was an herbivore. During the late Cretaceous, flowering plants were not widespread, so it likely fed on ferns, cycads, and conifers. It used its sharp beak to bite off branches, which were then shredded by its tooth batteries. These teeth created a continuous, self-sharpening cutting edge that efficiently processed plant material. With its large gut, Pentaceratops could digest tough vegetation, extracting nutrients from fibrous plants. The combination of its powerful jaws and digestive system made it well adapted to its Cretaceous environment. Liopleurodon was an apex predator of the Jurassic seas, possessing a powerful bite with large, deeply embedded teeth measuring up to 20 centimeters. Its skull accounted for about 1/5 of its total body length, making it a formidable hunter. It had 4 strong paddle-like limbs, which provided excellent acceleration, a crucial advantage for an ambush predator. Its nostrils were arranged in a way that suggests it had a directional sense of smell, allowing it to detect prey from afar, possibly even sensing blood like modern sharks. This feature would have helped it locate food before visual contact was possible. Despite its depiction as a 25-meter giant in Walking with Dinosaurs, real estimates suggest adult Liopleurodon ferox range between 5 and 7 meters long. The most complete specimen measured 6 meters, with a skull length of 1.3 meters, a pliosaur skull found in 2013, attributed to Liopleurodon, measured 1.5 meters, suggesting an individual exceeding 7.5 meters in length. Though its 4-flipper propulsion system was not the most efficient, it allowed for rapid bursts of speed, making Liopleurodon a deadly predator. A stomach analysis of a young Liopleurodon specimen revealed remains of cephalopods, fish bones, and a reptilian tooth. This suggests a varied diet, though its exact feeding habits remain uncertain. One theory is that it primarily fed on abundant prey like squid, though this would require ambush tactics due to the squid speed. Another possibility is that Liopleurodon was an opportunistic feeder, consuming a range of prey, though the absence of otoliths in its gut suggests fish were not a major part of its diet. A third theory proposes it preyed on large cephalopod eaters, indirectly consuming squid through their stomach contents. Interestingly, the specimen contained at least 7 gastroliths. These may not have been used for grinding food, as the cephalopod hooklets found in the stomach were well preserved. The stones could have been swallowed accidentally or represent acid-resistant residues from ingested carbonate-rich material. Liopleurodon was a top predator in its ecosystem, using its powerful bite, strong swimming ability, and advanced sense of smell to dominate the Jurassic seas. Despite limited fossil evidence, studies continue to refine our understanding of its size, diet, and hunting strategies. At least 4 Herrerasaurus were created by InGen inside their compound on Isla Sorna and shipped to Isla Nublar, where they lived in their own paddock, but the animal was never seen on screen. On the map, Herrerasaurus enclosure is located at the far northwestern end of the island where the tourist route does not connect. This population went extinct between the 1993 incident and the 1994 cleanup. InGen did, however, save 60% of its genome. There is evidence that mosquitoes existed during the Triassic period around 226 million years ago. Scientists have found amber from that period, meaning that Herrerasaurus must have been created using DNA from drops of blood or pieces of flesh preserved in amber. For many years, the classification of Herrerasaurus was unclear because it was known from very fragmentary remains. It was hypothesized to be a basal theropod, a basal sauropodomorph, a basal saurischian, or not a dinosaur at all, but another type of archosaur. However, with the discovery of an almost complete skeleton and skull in 1988, Herrerasaurus has been classified as an early saurischian in most of the phylogenies on the origin and early evolution of dinosaurs. Herrerasaurus was a carnivorous dinosaur that likely preyed on small to medium-sized herbivores, including early dinosaurs like Pentaceratops. However, it may have been preyed upon by larger predators like Saurosuchus, as one fossilized skull showed puncture wounds. Coprolites found in the Esquigualasto Formation contain small bones, but no plant material, suggesting Herrerasaurus could digest bone. Analysis of its scleral rings indicates that it may have been cathemeral, meaning it was active throughout the day at short intervals. A study in 2001 examined multiple Herrerasaurus hand and foot bones, but found no evidence of stress fractures, suggesting it did not regularly engage in high-impact activities that might cause such injuries. One fossilized skull showed bite wounds with signs of infection, likely from a fight with another Herrerasaurus. These wounds, found on the skull and jaw, were swollen and porous, indicating short-lived but non-lethal infection. The angle and size of the injuries suggest intraspecific combat, possibly over territory or mates. And finally, I can talk about my favorite dinosaur. During the early development of Jurassic Park, Phil Tippett advocated for replacing Apatosaurus from the novel with Brachiosaurus, as he found them larger and more interesting in design. Screenwriter David Koepp mistakenly referred to Brachiosaurus as Brontosaurus, which is reflected in the final film when Tim misidentifies them. It is also interesting to note that the appearance of Brachiosaurus is based on the fossil found in Tanzania and displayed at the Berlin Museum, a fossil that has since been reclassified into its own genus, Giraffatitan, with its iconic crest on the head being much more pronounced than in Brachiosaurus. To design the Brachiosaurus, Mark McCreary studied elephants to capture its mass, weight, and leathery skin texture. Stan Winston's team built a 3 meters tall animatronic head and neck with a 4-axis jaw to mimic a cow chewing cud. Brachiosaurus was the first CGI dinosaur completed for the film. Steven Spielberg frequently critiqued its design and requested a larger size. When they made it too tall to reach branches, adjustments were made to lower its head. Their sounds were a mix of swans, geese, elephants, cows, and donkeys, with the latter's vocalizations slowed down for singing effect. Empire magazine ranked the first Brachiosaurus encounter as the 27th most magical moment in cinema history. InGen recreated 10 Brachiosaurus in their compound on Isla Sorna, where workers cared for them. Once they reached a certain age, they were transported to Isla Nublar to be part of Jurassic Park, living alongside Parasaurolophus in a designated enclosure. The Brachiosaurus was the first dinosaur encountered by the endorsement team evaluating Jurassic Park. Dr. Alan Grant and Dr. Ellie Sattler were especially amazed, realizing that Brachiosaurus was terrestrial rather than semi-aquatic as previously believed. After Dennis Nedry disabled the park's security systems, Brachiosaurus and other dinosaurs were free to roam. Later, Grant, Tim, and Lex encountered a herd feeding in the trees and successfully imitated their calls. The next morning, a sick Brachiosaurus woke them up while feeding near their tree. Initially frightened, Lex calmed down after seeing the dinosaur's gentle nature. She attempted to pet it, but was sneezed on instead. following the Isla Nublar incident in 1993, the fate of its Brachiosaurus population was uncertain. However, reports suggested that at least 5 survived by October 1994, though one died from malnutrition. On Isla Sorna, Brachiosaurus were set free after the human workers evacuated due to Hurricane Clarissa. They survived by feeding on lysine-rich plants. The Isla Sorna Brachiosaurus had different coloration from those on Isla Nublar, featuring beige skin with green stripes. Some had dark red crests, possibly indicating males of the species. Brachiosaurus was once thought to be semi-aquatic due to its massive size, but early 20th century studies suggested it was fully terrestrial. Riggs argued that its hollow vertebrae and limb structure indicated specialization for land movement. This idea was initially ignored but gained acceptance in the 50s. Brachiosaurus had a stiff torso, allowing only quadrupedal movement. Some researchers suggested it might have entered water occasionally for thermoregulation. There is debate about its neck posture, with theories ranging from near vertical to horizontal. In 1999, Stevens and Parrish argued for a horizontal neck, but others defended an upward-sloping position. Some studies support a giraffe-like posture, requiring less energy to maintain. Holding its head high would have stressed its cardiovascular system, demanding a strong heart. Research on its inner ear suggests Brachiosaurus moved its neck laterally while feeding. It was a high browser, feeding on foliage over 9 meters above the ground. Its diet included conifers, cycads, and tree ferns, with an estimated daily intake of 200 to 400 kilograms of plant matter. It likely swallowed food whole, relying on hindgut fermentation for digestion. Brachiosaurus may have had niche partitioning with other sauropods, avoiding competition by feeding at greater heights. Unlike some sauropods, it was poorly suited for rearing on its hind legs. Its nostrils were traditionally thought to be on top of its head, but modern studies suggest they were near the snout tip. Some researchers proposed that its large nasal openings helped with smell, or even supported ornamental structures. The idea of a trunk-like proboscis has been debated but lacks strong evidence. Brachiosaurus was likely homeothermic and endothermic, maintaining stable body temperature through a high metabolism. It had an advanced air sac system, improving respiration efficiency and reducing skeletal weight. Air sacs also helped with heat regulation. Its growth pattern shows changes in neck and limb proportions over time. Juveniles had shorter necks and more robust humeri, which elongated as they matured. Its vertebrae became increasingly pneumatized with age. Studies suggest that Brachiosaurus could reproduce before reaching full size. These findings help clarify its physiology, lifestyle, and ecological role in the Jurassic period. Chungkingosaurus geongbaiensis was one of the smallest known stegosaurs, measuring less than 4 meters in length. Despite its small size, the ossification of its sacrum suggests it was an adult. It closely resembled Tujiangosaurus, which was found in the same geological formation. However, it differed in several anatomical features, including a smaller body size, a deeper snout, and a relatively high and narrow skull. Its teeth were distinct, as they did not overlap and had less pronounced denticles. Like other stegosaurs, Chungkingosaurus likely had 2 rows of plates and spikes running along its back. These were probably arranged in pairs, but the exact number remains unknown. A skeletal model displayed at the Chongqing Municipal Museum includes 14 pairs of plates and 2 pairs of tail spikes. The plates had a thickened middle section resembling modified spikes. This feature is also seen in Tujiangosaurus. The exact structure of its thagomizer, the set of tail spikes used for defense, is known from a specimen that preserved 2 pairs of robust, obliquely vertical spikes. Dong and colleagues reported that a 3rd pair of spikes, originally present in front of the others, was lost during excavation. A unique characteristic of Chungkingosaurus was an additional pair of long, thin spikes at the very end of its tail. These spikes were oriented almost horizontally and angled outward in a top-down view. Paleontologist Gregory Paul referred to this tail weapon as a pincushion array. The thagomizer of Chungkingosaurus is not well known, as no fully articulated remains have been found. Like all stegosaurs, Chungkingosaurus was herbivorous, feeding on low-lying vegetation. It coexisted with various large herbivorous dinosaurs, including the long-necked sauropods Mamenchosaurus and Omaisaurus. It also lived alongside other stegosaurs such as Kyalingosaurus and Chungkingosaurus. Chungkingosaurus may have been a target for large theropod predators, including Yanquinosaurus. In the early 90s, InGen had completed 12% of the Allosaurus genome for exhibition in the original Jurassic Park on Isla Nublar, but this completion of its DNA sequencing had to be put on hold due to InGen's financial trouble. The sequencing of its DNA would eventually be finished by the time that Jurassic World opened up to the public. During the eruption of Mount Sibo in 2018, one juvenile Allosaurus was encountered during a stampede of dinosaurs. Several Allosaurus were transported off the island to the Lockwood family's estate in California. At least one was successfully sold at the Lockwood Manor auction, while the others were released into the wilds of Northern California alongside numerous other species by Maisie Lockwood. Allosaurus had a relatively modestly sized skull for a large theropod, measuring around 85 centimeters in one specimen. Its skull was lightweight yet robust, equipped with numerous sharp, serrated teeth that were frequently shed and replaced. The upper jaw contained 14 to 17 teeth per side, while the lower jaw had a similar count. The skull featured a pair of distinctive horns above the eyes, possibly used for display, sun shading, or interspecies combat. Its brain case was thin, likely for thermoregulation, and the jaws had flexible joints that allowed for increased gape. The vertebral column consisted of 9 cervical, 14 dorsal, and 5 sacral vertebrae, while the tail had an estimated 45 to 50 vertebrae. Hollow spaces in the vertebrae suggest an air sac system similar to modern birds. Allosaurus had a barrel-shaped chest and a well-developed pubic foot, possibly aiding in resting posture. The forelimbs were relatively short but strong, with 3-fingered hands ending in large curved claws. The hind limbs were not optimized for speed, but juveniles had longer lower legs, suggesting they were faster than adults. Skin impressions suggest Allosaurus had small scales covering its body, with larger scales near the tail, though some impressions may belong to other dinosaurs. Growth studies indicate it reached maturity around 15 years, with a lifespan of around 25 years. The discovery of medullary bone in one specimen suggests it was capable of egg-laying, though this has been debated. Juveniles had proportionally longer limbs and likely hunted smaller prey before transitioning to ambush hunting as adults. Allosaurus was an active predator, attacking large dinosaurs like Stegosaurus and possibly scavenging on sauropods. Evidence of bite marks on Stegosaurus plates and sauropod bones suggests it fed on both live and dead prey. Some researchers propose it used a hatchet bite, swinging its upper jaw downward to slash prey, while others believe it grasped and tore flesh like modern big cats. Its jaws could open to 92 degrees, wider than Tyrannosaurus. Biomechanical studies suggest Allosaurus processed carcasses using vertical head movements similar to birds of prey. Its binocular vision was limited, but likely sufficient for ambush attacks. The strong forelimbs may have helped grasp prey, and its feet had an inner dew claw, possibly used for gripping. Some evidence suggests it scavenged large sauropod carcasses, supporting injured individuals. While some paleontologists propose Allosaurus hunted in packs, there is little direct evidence for social hunting. Bite wounds on skulls and broken bones indicate frequent interspecies aggression, possibly for dominance disputes. It may have engaged in occasional cannibalism. Despite these debates, Allosaurus remains one of the best-known theropods, providing valuable insight into Jurassic predator behavior. The ability of Muttaburrasaurus to move quadrupedally has been a subject of debate. Initially classified as an iguanodontid, recent studies suggest it belongs to the rhabdodont group. Basal ornithopods like this were incapable of quadrupedal locomotion, while early reconstructions depicted Muttaburrasaurus with a thumb spike. Molnar later questioned the presence of such a structure. Its foot was long and broad, featuring 4 toes. The skull of Muttaburrasaurus was relatively flat, with a triangular cross-section when viewed from above. It had a broad back of the head and a pointed snout. A distinctive feature of its snout was the strongly enlarged, hollow, upward-bulging nasal structure, which may have been used for vocalization or display. However, since no fossilized nasal tissue has been found, this remains speculative. This so-called bulla nasalis was shorter in the older Muttaburrasaurus sp, as evidenced by the Dunluce skull. The upper section of the bulla in the holotype specimen has not been preserved, but at least one other known skull exhibits a rounded profile. It had powerful jaws equipped with shearing teeth. Unlike more derived ornithopods, where replacement teeth alternated with previous generations to form a tooth battery, in Muttaburrasaurus, the new teeth grew directly beneath the existing ones, with only a single functional generation at a time. This arrangement prevented a chewing motion. Another primitive trait was the absence of a primary ridge on the tooth surfaces, which instead displayed 11 smaller ridges. In 1981, Molnar hypothesized that these dental features suggested an omnivorous diet, possibly including scavenging. However, in 1995, he revised his view, proposing that Muttaburrasaurus's dentition was evolutionarily convergent with the shearing teeth of ceratopsians. This adaptation would have been suited for consuming tough vegetation, such as cycads.